So this video is a repeat of something that you did in grade 11, the cast rule, except this time we're going to use radians instead of degrees. The mechanisms are the same, just the notation is a little bit different. So the first thing that we need to remember are the two special triangles that we have. So the first triangle is the 45, 45, 90 triangle. And in radians, that is pi over 4, pi over 4. And then this one is pi over 2. Our side lengths are 1, 1, and root 2. And I'm just going to put down that 45 degrees is equal to pi over 4. The second one that we have is the 30, 60, 90 triangle. So this is pi over 6, pi over 3, and then pi over 2. So we've got pi over 3 is equal to 60 degrees. And then we've got pi over 6 is equal to 30 degrees. You can do the calculation to check, but those are the equivalencies. So those are our two special triangles. And this one we've got 1, 2, and root 3 as our sides. So the first thing that we're going to do is we're going to write down all our ratios based on each sort of special angle here that we can use to calculate. I don't memorize these. I always write down the special triangles and then calculate the ratios from there, but some people do like to measure them. So let's take a look at an angle in standard position. So we're measuring from the positive x-axis, and I know that 45 is half of 90, so I'm going to try and draw, the best I can right here. So this angle is 45 degrees, or pi over 4, and I know that that creates a right-angled triangle with the x-axis. My sine ratio is opposite over hypotenuse, and here I've got my opposite side is 1. I know that from my special triangle, and I know that my hypotenuse is going to be root 2, also from my special triangle. So that means my sine ratio for the angle pi over 4 is going to be my opposite side over the hypotenuse. My cosecant ratio is just the inverse of that. My cosine ratio is the adjacent over hypotenuse. My adjacent side to pi over 4 is 1. My hypotenuse is root 2. And again, the secant ratio is just the reverse of that. The last one is my tan ratio. I've got opposite over adjacent, and in this case those sides are both equal, just 1 over 1, and then my cotan ratio is just the inverse of that. So those are all your primary trig ratios for pi over 4 in standard position. We're going to do the same thing now for pi over 6. So this was the same as 45 degrees. This is the same as 30 degrees. So I know that's a little smaller. I'll try and make my diagram kind of accurate. Okay, so I've got 1, 2, and root 3, and then I've got my angle, pi over 6, that I'm calculating all my trig ratios from. So my sine ratio is opposite over hypotenuse, so 1 over 2. My cosecant ratio is just the inverse of that. Cosine of pi over 6 is adjacent over hypotenuse, and the secant is just the reverse. Tan is going to be my opposite side again, so that 1 over the adjacent side, which is root 3, and then I can flip those around to get my cotan ratio. Our last special angle that we need to do is pi over 3, which is 60 degrees. Draw that up here. So I've got pi over 3 is my reference angle. And then I've got the side lengths 1, 2, and root 3. My sine ratio is opposite over hypotenuse. So this is root 3 over 2. My cosecant ratio is just the inverse of that, so 2 over root 3. Cosine is my adjacent side over the hypotenuse, and then I flip those around for the secant ratio. Tan is going to be my opposite over adjacent, and then I can flip those around. So now what we're going to do is we're going to use those ratios in a little bit to calculate the exact value of some trig ratios. Okay. Now what we want to be comfortable doing is figuring out where these values lie on our axis, on our wheel. So this right here, where we start, that is 0 radians. We're going to go all the way up to 90 degrees, which is the same as pi over 2 radians. We're going to keep going down to the negative y-axis. That is 180 degrees, or pi. We continue on to 270 degrees down at the negative y-axis. This is the same as 3 pi over 2. And then coming all the way back around, we've done one full revolution of 2 pi. We also want to be familiar with the trig graphs. So sine is going to start at 0, goes up to a maximum, back through 0, down to a minimum. And these minimums, maximums, and 0, they all happen at sort of those axes on the rotation. So we've got 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Cosine starts at a maximum, goes down to a minimum, looks more like a cup. All of those things also happen at those axes values as well. So we've got those for reference, and we're going to use those to solve some problems. So the first thing we're going to do is find the value of each trig ratio. So I'm going to draw my angle right here. So 5 pi over 4. Well, I know that 4 pi over 4 would be equal to pi over here. So I know that 5 pi over 4 must be a little bit past. So that means that this angle, whoop, this is my angle 5 pi over 4. Once I've drawn the angle, so let's say first, we'll say draw angle in SP, or standard position. Okay, the second thing that you're going to do, and hopefully this is familiar from grade 11, you're going to find your related acute angle. That is the distance from the angle that you've drawn in standard position to the nearest x-axis. And then in order to find that related acute angle, we're going to take our given angle, and then we're going to take away the value of an angle that would go to that axis here. So our related acute angle is going to just be pi over 4. In order to use the special triangles, it either has to be pi over 4, pi over 6, or pi over 3. So once we found that related acute angle, that is the first thing that we're going to do, and we're just going to call it theta. Now we can use the special triangles to find the cosine of that related acute angle. So I can go back and look up at my chart here. I've got cosine 45 degrees, or cosine of pi over 4. I can see right here that it's 1 over root 2. I can also see that from my triangle. My adjacent side is 1. My hypotenuse is root 2. The fourth step is to determine the sine. So this is where the cast rule comes in. So I start here and I go C, A, S, T, and that tells you which trig ratio is positive in which quadrant. So I am in, the angle that I originally drew is in the third quadrant, and cosine is negative in there. So then I can state my answer by saying the cosine of 5 pi over 4 is equal to 1 over root 2, because it is equivalent to the cosine of the related acute angle, but because that angle 5 pi over 4 is in the third quadrant, it is negative, and that's my exact value. Let's try another one. So here we're going to look at the cosecant of 11 pi over 6. So the first thing I'm going to do is draw my angle. So I know that 12 pi over 6 would be 2 pi. So 11 pi over 6 must be a little bit less than that, but it's a pretty big angle. So this is 11 pi over 6. So the second thing I'm going to do is I'm going to find my related acute angle. And this is a step that I do expect you to show, and I do expect you to write down. So I'm going to show that this is my related acute angle. I'm going to call it theta. And I'm going to say that theta is equal to 2 pi, take away 11 pi over 6. So my related acute angle is going to be pi over 6, which conveniently matches one of our special triangles. So then the next thing I'm going to do is I'm going to find the cosecant ratio of pi over 6. That is related to sine. Oh, actually, I've got that on my chart. I'll go back up here. So my cosecant ratio of pi over 6 is right here, is just 2 over 1. And now I'm checking the sine. So put on my cast rule here. So in quadrant 4, cosine is positive, but we don't have a cosine ratio. This is a sine related ratio. So then my final answer is that cosecant of 11 pi over 6 is equal to -2. Because the only ratios in there are cosine and then secant, but we don't have either of those, so it must be negative. We're not going to do this one. We're just going to move on to these exact values here. Anytime I see exact values and they're numbers that are pi or pi over 2 or 2 pi, I do always like to draw little sketches of the sine graph, a sketch of the cosine graph, and in this one we're also going to need a sketch of the tan graph, and that just helps me to see the features so I can figure out which one I'm looking for. So these are at x equals pi over 2 here, these asymptotes, and x equals minus pi over 2. So we're looking for the exact value of each trig ratio. So the first one I'm looking for, sine pi. Well, sine pi is right here. This is pi, or 180 degrees. And I know that that's a minimum for sine. So I'm going to say that this is equal to 0. The next one, I guess I can keep using red because I'm doing different questions. 3 pi over 2. That is the same as 270 degrees. That is right here on this graph. Okay, on the sine graph, it would be right here. And so based on my graph, I can see that that would be, so the cosine of 3 pi over 2 is equal to 0. So then my secant ratio, when I flip that, is going to be undefined. Okay, and then the next one that we're doing is tan of pi over 2. This one's a little trickier because you do need to know that there's actually an asymptote at x equals pi over 2. So this is also undefined here. And then the last one, cosine of 0. I'm going to go back to my cosine graph. And now I've got cosine of 0, which is right here. And I can see that that cosine is going to be equal to 1 because it is a minimum. Sorry, it's a maximum. Cosine starts at a maximum. So that is using the graphs to find some of those values that would lie right on the axes if we were to use the cast rule, and knowing those key points in the trig ratios. Okay, so now this B we're going to do for warm up on Thursday, but we'll go through example 3A here. So we want to find the exact value of each expression. So we're going to have to find the value of each trig ratio separately. So it's like 3 questions in one. So the first one isn't too bad because pi over 6 is one of our special angles. So if I go all the way back up to the top, I'm looking for cos of pi over 6. I've got that right here. That's root 3 over 2. The second one, now I've got sine of 7 pi over 4. So I'm going to draw my angle first. I know that 8 pi over 4 would be all the way around, so that must be right here. Oops, C-A-S-T. I'm looking for my related acute angle, which is going to be, really, it's 2 pi, take away 7 pi over 4. So that's going to give me pi over 4, which matches one of our special angles. Then I'm going to do the sine of my related acute angle, which is 1 over root 2. But I'm looking for the sine of 7 pi over 4. So now I'm going to look at the sines. So in the fourth quadrant, sine is negative. And so what that means is my second question, sine of 7 pi over 4 is going to be equal to negative 1 over root 2. The last question that we need to solve is tan pi over 4. So I'm going to start the same way. I'm going to draw where my angle would be in standard position. So I know that 4 pi over 4 would be 180 degrees, or pi. So that must mean that I'm a little bit past it. I'm going to put on my cast rule notes. And then I'm going to find my related acute angle. So my related acute angle is here. In that third quadrant, in order to find my related acute angle, I'm taking my angle that I drew, so 5 pi over 4, and I'm going to take away the value of the angle that would go to the x-axis. So I'm going to take away pi. So my related acute angle, again, is pi over 4. We'll label it as theta. Then I'm going to do the tan of my related acute angle, and that is equal to 1. And then I'm going to apply my rules for the quadrant. So in quadrant 3, tan is positive. So that means the answer to my third question, tan of 5 pi over 4, is going to be equal to just 1. So now the last thing that I have to do, I'll sort of draw a line so it organizes a little bit better, is I'm going to multiply those 3 values together, because that is going to give me the exact value of my expression. So I've got root 3 over 2 times negative 1 over root 2 times 1, which is going to leave me with minus 3 over 2 root 2.